Again, welcome to Enterprise Database System, INFO 620 class. This is Introduction to Database lectures. Our main objective is to go through types of databases and also the applications. Also the definition of database system and some of its terminologies. Also typical database management system functionalities, the main characteristics of database approach, types of database users, and advantages of using a database approach. So we start with the traditional applications, which are normally the numeric and also textual database. These are databases that make it possible for us to store a text data or numeric data values. Most recently applications, we have the multimedia databases, also geographical information systems databases, biological and genome databases, data warehouses, mobile databases, and also real-time and active databases. So we go through each of them. We start with the numeric and also the textual database. And again, numeric database make it possible for us to store values and data. And textual database make it possible for us, again, to store text data. So a database provides a numeric information such as statistics or demographic information, or I would say the quantitative data. Then traditional textual database normally interfaces allow users to search an index composed of exclusively of terms extracted from documents. And also the textual database make it possible for us to store text data from a document, also data. The multimedia databases, again, multimedia database system is a collection of related for multimedia data. So a multimedia data can include one or more primary media, such as text, images, but most of these data are multimedia. And also we have the mobile databases. And we know mobile computing devices such as smartphones or personal digital assistants can store and also share data over a mobile network or a database which is actually stored by a mobile device. So a mobile databases are normally database systems that are stored in mobile devices. A very good example is our smartphones. So this could be a list of contacts, the price information, distant travel, or any other information. We also have the geographic information system database. And geographic information system, again, is a computer system that capture, store, check in, and also display data that are related to positions on Earth's surface. So these are geographical information system. By relating similarly unrelated data, GIS also can help individuals and organizations better understand spatial patterns and also relationships. So a geographical information system database normally store data that are related to geographical informations, or I would say the Earth surface, basically related to spatial data also. And the biological and genome databases. Again, a biological database normally store biological data such as genome or DNA, RNA, protein data set. We have a nucleic acid and also protein sequence that are also stored in a sequence database. And this makes it possible for us to analyze DNA sequences or protein sequence to predict the function of each protein. And also the structured database or system. And system also make it possible for us to store the structure of protein database or the RNA database. The human genome database are normally referred to as online repositories of genomic variants, mainly described for single or more genes, or specifically for a population or ethnic group. So the concept of genome data or human genome is that it's a person's or a human complete DNA sequence. And this data can normally be analyzed or again, sequentially. And this makes it possible for us to determine the function of each protein in a human genome. So a data warehouse normally will be a place where a company will store their historical data. And these data are normally important for analysis to find a pattern or some decision-making process based on previous activities of the company. So a data warehouse is a type of data management system that is designed to enable and also support business intelligence activities, especially, again, analytics. So data warehouses are solely intended to perform queries and analysis and often contain large amounts of historical data. Most business organization data warehouse systems are data that are at least over a year old to somewhere around 10, 20 years old. So these are historical data that when a company decided to analyze it, they can find a pattern related to the company's business operation for a specific period of time. And this can even make it possible for a company to predict a future phenomena that will occur in the company, maybe business or expenses, profits, etc. So the data within a data warehouse is usually derived from a wide range of sources, such as application log files, transaction applications. Majority are transactions applications. And a data warehouse also can centralize and also consolidate large amount of data from multiple sources. A very simple example would be most companies have more than one department. So maybe a company have accounting department, HR department, and etc. The data from each department can be centralized as one unit in a data warehouse. We also have a real-time database. Normally, a real-time database is based on time constraints. It's based on time. A very good example would be the stock market. A stock market, again, prices or activities are real-time activities. So here we say a real-time database is a database system which uses a real-time processing to handle the workloads whose state is constantly changing. A very good example would be the stock price. Stock price is something that's constantly changing. And this differs from traditional databases containing a persistent data. A normal traditional database, the data are permanent, doesn't change, persistent data, mostly unaffected by time. But a real-time database, again, changes based on time. We have like temporal data, or again, stock market changes very rapidly and it's very dynamic environment. So the recent development in database systems, again, we know the social media. Example here, we have a Facebook, Twitter, LinkedIn. These are all companies that their major operation is based on data. It's based on data. So there are so many, again, activities involved here. So here we say social networks started capturing a lot of information about people, about communication among people, posts, tweets, photos, videos in systems such as Facebook, Twitter, LinkedIn. All of the above constituents data. We say that Facebook, Twitter, and LinkedIn, 90% of their business operations is involved data, if not even 100%. Search engines just such as Google, Bing, Yahoo, all these collect again their own database system of web pages for searching purposes. And new technologies are emerging from the so-called non-database software. One example can be the crowd system also. So vendors to manage vast amount of data generated on the web. We also have the big data storage system, which involve again large clusters of distributed computers. We have new system called the not only SQL system, non-SQL. This also involve a large big data set. So a large amount of data now reside on the cloud, which means it is huge data cluster using thousands of machines. So we start with the basic definition. Again, most of the lectures we cover so far again is database applications and different types of database applications. Now we start with the basic definition. We know what is a database. Again, database is data, or we say a collection of related data that are stored electronically in a computer system. Also, we can say it can be hardware, but a database is a collection of data or related data. And what is a data? A data can be a raw fact, data can be audio, it can be a text, it can be video, but it's a fact. So here we say data is a known fact that can be recorded and have an implicit meaning. It must have a meaning within the data itself. Then the meaning world, we say some part of the real world about which data is stored in a database. So for example, student grades and transcripts at a university. So a meaning world is some part of the real world about which data is stored. For example, in a university or even a working environment. Then the database management system is the software. So here, most students again confused with these two terminologies. A database is just the collection of data that are stored electronically or any means of storage. But a database management system is the software that we are going to use to manage our database. That's our collection of data, storage of data. So here we say a database management system is a software package or system to facilitate the creation and maintenance of a computerized database. So a database system is a software together with the data itself. Sometimes the application are also included. That's for database. So database is a collection of related data. Database management system is the software that we use to manage or even create or computerize our database. And then the database system, that's the combination of, that's the whole system now. So it's the combination of the software and also the data. So the impact of database and also database technology in terms of business, we know almost any business organization today use a database management system. Data are stored electronically, computerized, or even digitized. Way back, let's say 50, 100 years ago, data are not stored most data, again, are stored hard copy on the files and folders. You may visit a clinic in the 80s, and most likely your medical records are stored in a file cabinet. You go to the clinic, they call your name, they go and pull your file for you folders. They will even give it to you, or they may take it to the doctor's office, then you go and visit. Doctors don't use personal computers those days, let's say in the 70s. But today, if you visit even any business organization, most likely you will never see a file cabinet because it again consumes a lot of space in the office. So you visit a clinic, the receptionist will go to the computer pull your record. Maybe you made a record or transferred a record to the doctor's system, and everything is done electronically. So this is one of the impacts of a database technology in the medical field. Banking industry, insurance, retail, transportation, manufacturing, again, most of all these businesses use a database system. And the service industries such as financial, real estate agents, legal, electronic, commerce, small business. Today, most likely there's no any business organization or any industry that does not use a database system, because every business or every organization must store some data. Right now, we are living in a data-driven society. Any activity we perform, we generate data. Even using a cell phone, we still generate data to our cell phone subscriber at the company. So more recently, again, social networking, example will be Facebook, Twitter, Instagram. Again, we generate data. Environmental and scientific applications, medicine and genetics. Actually, medicine is where we talk about the human genome. Again, their database system. This is a DNA sequence or even DNA, protein, RNA data that's supposed to be hard copy, but today these data are turned to a computerized database system, which even drives us to something we call the personal medicine. A personal medicine is using a person's DNA or genome, full complete of the DNA sequence and protein, analyze it. From there, we can tell what kind of disease the person is prone to based on his DNA sequence and his genes also. We have something we call transformational medicine also, the same concept, using data driven, medical data driven system to again diagnose patients. Personalized applications, here we say based on smartphone, mobile devices, and GPS, our daily activity. Even we have a smartphone that again, for fitness, it can monitor how many miles you walk or you run or your activity. All these are data generated system, and this data must be stored somewhere. So this is our simplified database system environment. For example, in a specific company, we may have the users and programmers at the application, programs and queries interface. Then between here, we have our database management system. This will consist of the software to process the queries and programs, and also the software to access the stored data. Then the actual database, which is the data that is stored. So this will be our stored database. Then sometimes again, we may talk about this in the future lectures. A stored database definition, what we mean by metadata means a data about a data. So for example, I may create, if I'm having a relational database, I may create a table, and the table may have some attributes or fields. Let's say a field of last name. And I may have a metadata, that's the data about the field. What is the field data type? What type of data I can enter in, and the characteristics of the field, I mean to say. And we may discuss what is metadata again in the future lectures to come. So this is a typical environment of a database system. We may have the storage of our actual business transaction data, the business data. Then we may have a storage about the metadata, that is data by the database system objects. Then we may have a software that can access our data. Then we have a software that can query our data. And in SQL, which is the main script language we use in database management system. We have two types. We have the script for, again, creating our database objects, and we have the script for manipulating our data, which we call the data manipulation. And then data definition is what we use to create our database objects, such as a table, index, etc. So we define typical database management system functionality, define a particular database in terms of database data types. As we said earlier, we may have a field, last name, what is the data type, what kind of structure, what constraints we may have in that field. Then construct or load the initial database content on a secondary storage medium. So that's the data definition concept. Then manipulating the data, we can have a query to retrieve any data from the database system, or even generate a report to print out from the database system. And when we say retrieving a data query, let's say we have a database system of a retail store, and then I have over millions of transactions for the past few years, and I want to know which customer spend more than $1,000 and what state they are from. So I cannot go through millions of transactions. So what I'll do, I'll write a query, and my query condition will be, I need all the customers that they spend more than $1,000 and what state they are also from. Then when I run this query, within seconds, I'll get a result. So modification means maybe I have a field or a table already, I'm going to set a new field or new column. Let's say I have a table and I have only the last name. I may decide to modify the table to insert first name or middle name, or maybe delete the middle name. So retriever is selecting something. So query or generating report. Modification means I'm going to modify the database object, either inserting something or deleting or update to its content. Then accessing the database again through the web application. These are some of the functionalities of manipulating database system. Also processing and sharing by a set of concurrent users and application programs, yet keeping all data valid and consistent. So application activities against a database. We said application interact with database by generating queries. We say queries that access different parts of data and formulate the result of a request. So I can write a query, how many students are from New York? How many customers spend less than $2? Or how many customers are from outside US? We can write, a query is more or less a question. So you question the system, and the system give you the answer, or you request, give you the answer. Transactions also very important. So transaction that may read some data and update certain values, or generate a new data and store that in the database. Most of the time, transactions always generate a new value, unless there's old transaction that we need to update based on customer requests. So applications must not allow unauthorized users to access the data. So every database system, that is database management system, have some security. At least a common security can be authentication. Provide your username and password before you can access the database. So application must not allow unauthorized users to access data. And also applications must keep up with changing user requirements against the database. And also we have database management system may additionally provide security measurements or protection. And here again, to prevent the unauthorized users, and also active processing to take internal actions on data, presentation and visualization of data, maintenance of the database, and associated program over a lifetime of the database application. And it's called the database software and system maintenance. So this is where we're going to end our first lectures for our class and enterprise database systems. So in summary, we learned about different types of database and also the database applications, such as we talk about the mobile database, biological or genome database, etc. Now, so we discussed about the basic definitions, what is a database, and also typical database management system functionalities. Most important, I would say, by this functionality is protection and security. Because we know data is very, very, very valuable product for any business organization. So business organizations do not play with their data. From data, decisions are made. Example would be the business intelligence concept, decision are made. So it's a very valuable asset. Data is a very, very, very valuable asset to any business organization. So protecting it and making sure unauthorized person cannot access it is one of the important functionalities. Then also modification, retrieval, networking system be able to share data with different locations, accessing very quickly. Those are all important functionalities of a database system. So again, we end here and wish everybody the best. Again, this is our first lectures. We're soon going to get to the second. So this is half of chapter 1 of the course textbook. We're going to talk the remaining part of chapter 1, which will be example of a database. We'll see how database, especially relational. This course will be based on relational database. So we see how the tables, reports, etc. works, entities, and how do we create a relationship between entities. So again, wish everybody the best. Thank you.